Hi. Now, before we dive into programming, we need to have a quick look about this idea called computational thinking. Computational thinking does not mean thinking like a computer. What it means is thinking logically and thinking mathematically. Computational thinking really is a process where you can break problems down, follow a set of steps, and come up with solutions. In fact, what we normally do is we say that computational thinking is a 5-step process, and the steps do not have to happen in exactly the same order every time. Usually, though, when we've got a problem to solve with computational thinking, we start by decomposing. That basically means we're going to take our problem and break it down into something simpler. Usually these simpler problems are also smaller problems, which makes it easy to work with. Then we start looking for patterns. Where are the similarities in the problems? i.e., where can we solve more problems by doing less work? Sometimes we'll then look for generalizations, where we can actually adapt our solutions to new problems. So we may have solved a little problem today. Could that be useful in the future? If we can, we try to generalize it. Then we get rid of all the extra detail that we don't really need. So just get down to the essential nuts and bolts. And then finally, this is where computer programmers step in, where we turn all that generalization, that abstraction, that pattern recognition into a set of simple rules that we can follow to solve a problem. That's an algorithm. That's what the computer actually does. It will follow an algorithm. Sometimes with funny results, simply because you program the computer to give you odd results. Now, this might seem like an overly complex idea, and we'll look at these different steps along the way. But I want you to think briefly about a problem that you probably solve at least once a week: tidying your room. Now, the problem there is you need to tidy your room so that your parents or your carers do not get upset with you, and so that you don't get infestations of cockroaches, spiders, and ants. But normally, when a teenager looks at their room, and I'm not saying this applies to you, but when a teenager looks at their room, it's usually very overwhelming and the problem is too big. So you break the problem down into smaller parts. You might start by putting away your workbooks from school from the week. You might also start by putting away your laundry. You might have make the bed. You might have vacuum the floor. These are all similar problems, but two of those were very similar. We had putting away our school books and we had putting away our laundry. Both require us to take an object. This is where we're abstracting. Take an object from where it is and work out where to put it away. So now we have a similar problem. We've recognized the pattern. We can break it down into our abstraction. It's no longer homework or laundry. It's just it's an object and it has a home. So now we can build an algorithm. Maybe it is identify object. Ask the question, where does object live? Place object away. That's not an efficient algorithm because we are doing the same job over and over again. So let's try to generalize that and make it a little bit simpler. Identify your homework books, your school books. Collect all your school books together into one place. Move the stack of school books from that one place to their shelf above your desk. There's less motion involved. It's a more efficient algorithm. Could that same algorithm be generalized to laundry? Collect all your laundry of the same type. Stack it together. Take it and place it away in the right drawer in your wardrobe. Do the next with the next one. This process of computational thinking, well, the example of tidying your room is very, very silly. The idea of breaking a problem down into its smaller parts, making it a little bit easier to tackle, and then solving those little problems step by step in such a way that we can reuse the algorithms. Computer programmers, they're inherently lazy. We don't like doing extra work just for the sake of it. We like to reuse the same ideas over and over again. It means once we solve the problems once, we don't have to keep solving them over and over again. It makes life easier. So as we go through this Arduino Ninjas course, look out for points where there are similarities in what you're doing. Do not feel afraid to go back and copy and paste something from an earlier problem if that algorithm is useful. And always try to say, what is the real problem I'm answering here when I'm trying to break this down into smaller and smaller chunks? So with that very brief overview of computational thinking, let's get into some real programming, and we'll come back to computational thinking as we go through some of the challenges. See you in the next video.